The discriminant is the name given to the expression that appears under the square root radical sign in the quadratic formula. That expression is b squared minus 4ac. Now, if it's positive, then we have two real roots. For x squared plus 6x plus 5, a is equal to 1, b is equal to 6, and c is equal to 5. b squared minus 4ac is equal to 6 squared minus 4 times 1 times 5, which is 36 minus 20, and it's equal to 16. Positive, therefore we have two real roots. If the discriminant is equal to 0, b squared minus 4ac is equal to 0, you have a double real root. The root is repeated. For x squared minus 2x plus 1, a is equal to 1, b is equal to negative 2, and c is equal to 1. b squared minus 4ac is equal to negative 2 squared minus 4 times 1 times 1, and 4 minus 4 is 0. b squared minus 4ac is equal to 0. You notice that x1 is the double root. If the quadratic is a perfect square, then the discriminant is equal to 0. X squared minus 2x plus 1 is a perfect square. X minus 1 squared. Therefore, the discriminant is equal to 0. If the discriminant is negative, the solution is imaginary. So we said there are no real roots, no real solution. For x squared minus 3x plus 10, b squared minus 4ac is equal to negative 3 squared minus 4 times 1 times 10. So it's equal to negative 31. No solution. Use the discriminant to determine the nature of the roots. X squared minus 2x minus 5. B squared is negative 2 squared minus 4ac minus 4 times 1 times negative 5. Negative 2 squared is 4. Negative 4 times negative 5 is positive 20. So the discriminant is 24, which is positive. Therefore, we have two real roots. X squared plus 2x plus 1 is equal to 0. B squared minus 4ac will be 2 squared minus 4 times 1 times 1. It'll be 4 minus 4, which is 0. So b squared minus 4ac is equal to 0. Therefore, we have a double root, or two equal solutions. By the way, x squared plus 2x plus 1 is a perfect square. It's x plus 1 squared. 2x squared minus 5 is equal to 0. When we add 5 to both sides, 2x squared is equal to 5. We divide by 2. X squared is equal to 5 over 2. And x is equal to plus or minus square root of 5 over square root of 2. When we rationalize by multiplying by square root of 2 over 2, we get x squared equal to plus or minus square root of 10 over 2. Therefore, the solution set is negative square root of 10 over 2 and square root of 10 over 2. The roots are real and irrational. Therefore, the correct answer is D. The sum and products of the roots. In general, ax squared plus bx plus c equal to 0 with a different from 0 has, for the sum of its roots, negative b over a. R1 plus R2 is equal to negative b over a. And the product of its roots, R1 times R2 is equal to C over B. Let's compare solving the equation with using the formula. If we were to solve this to find the sum and the product of roots, we would have to factor x squared plus 5x plus 6, which is x plus 2 times x plus 3. Set x plus 2 equal to 0 and x plus 3 equal to 0. And we will find first the roots. X is equal to negative 2 or x equal to negative 3. The sum will be negative 2 plus negative 3, which is negative 5. And the product will be negative 2 times negative 3, which is positive 6. Now the formula says to find the sum, just divide negative b by a. So it's going to be minus 5 divided by 1, the coefficient of x squared, and we get negative 5 quickly. The product, according to the formula, is c over a. So the product is just 6 over 1, which is 6. We're done. Here's a multiple choice practice problem. X squared minus 7x plus 2 is equal to 0. They want to know by how much the sum exceeds the product of the roots. For the sum of the roots, it's negative b over a. The product is c over a. First, we're going to identify a, b, and c. A is equal to 1, b is equal to negative 7, and c is equal to 2. The sum will be minus negative 7 over 1, which is positive 7. The product will be 2 over 1, which is 2. Now, the sum exceeds the product by how much? 7 minus 2 is 5. It exceeds the product by 5. So the correct answer is 5.